Okay, moving on to number 6. Which of the following is true? Okay, the product of two complex numbers is always real. So that's going to be false. And if you need an example, just take something like 2 plus I times 3 plus I, right? When we multiply these two complex numbers together, we are still going to have an imaginary part because our outer and our inner terms, our terms, outer term and our inner term, we multiply those two, we're still left with an imaginary component. So this is not true. B, the product of two complex numbers can be real. Well, that is true because if I choose these two numbers to be conjugates of each other, then the outer and the inner terms are going to cancel and we are just left with the real part. So this can be true. So this is true. I probably can stop there, but let's go ahead and just look at the others. The sum of two complex numbers is always complex. Well, if I choose the numbers so that the imaginary parts go away, right? If I add these two numbers up, the imaginary numbers go away and I'm just left with 4. So that's not complex. Although, I mean, technically that is a complex number, so I don't really love the wording of this. This could also be considered true, but I think they mean a complex with a non-zero imaginary part. So that would make this not true. All right, in part D, a quadratic equation may have more than two complex roots. So that's not true. So we know that quadratic equations have at most two roots. They could be real. It could be one real repeated root, so or with multiplicity 2. Or if the parabola doesn't hit the x-axis at all, we would consider that two complex roots. But certainly roots always come in pairs with complex values. And for quadratic, being a second degree polynomial, the most it can have is 2.